Hi everyone, welcome to the PyTorch Ecosystem Day. My name is Ritchie and I'll be talking about the applications of AI and PyTorch in Asia Pacific. Now my name is Ritchie Ng and I'm the CEO of Hessian Matrix. We are basically a global systematic AI fund where we digest multimodal data, petabytes of it every day, and we track the global markets. I'm also a visiting research scholar for quite some number of years in Next Lab in NUS School of Computing, where we do multimodal data digestion all the way for e-commerce use cases, all the way to the fintech vertical, where we also leverage on multimodal data in that space. Now, the second part is we'll be talking about the agenda, which basically we'll be covering the overview of AI applications as well as PyTorch progress in Asia Pacific, mainly from how it's used in the research all the way how it's used in production in the firms in APAC. The second part is we'll be talking about the computer vision algorithms in e-commerce companies in APAC, which is the most common use cases which we have seen. And third, it's in the case of natural language processing in finance, which is also a growing use case that I see in Asia Pacific. And finally, we'll talk about the recommendations of resources that we can leverage on, be it from the rudimentary theories all the way to applied machine learning, and followed by production resources where we can move to serve these algorithms to our customers, or be it end users in terms of retail end users or business end users. Now, the first part is the overview of applications of AI and the role of PyTorch in APAC. Now, I think it is quite common and a widespread scene that we see in APAC, in the sense that PyTorch is being used in a huge number of research labs, both in terms of the public research lab as well as the private research labs in corporations. And this is because of the user-friendly interfaces that allow it to basically iterate and prototype really fast from one experiment to another. Now, it is only recently that we see a growing use cases of PyTorch for production, and that is because there is a growing new number of features released by PyTorch, mainly the C++ interface, TorchServe, and mobile support, that is basically slowly being adopted by firms and being trusted by them to become end-to-end platform in terms of using PyTorch for research all the way to production use cases. But it is, of course, at its nascent stage at this moment. Now, one thing I'd like to say is a key differentiating factor which we see of PyTorch in APAC is that it is a rapid and flexible platform that allows a lot of researchers to production engineers that leverage on it to basically use a single framework instead of switching to many different frameworks, to basically move from research, rapidly iterate to make sure it works, and then serve it in production. And that is one of the unique use cases that people cite that is unique to PyTorch in this area compared to competing frameworks. Now, the first thing that we'll be talking about after reviewing what is happening in APAC is basically computer vision applications in Asia Pacific with PyTorch. And it is most prevalent, I see, in e-commerce companies. Now, the two cases I'll be highlighting here today, although they are not exhaustive by nature, but these are one of the most common cases which we see, and we see a growing number of adoption of these cases by smaller firms that is trickling down from larger firms. Now, in the e-commerce space, we have product discovery with automatic visual tagging, all the way to visually similar product recommendations, which is being done using computer vision algorithms. And then once you move from e-commerce to retail operations, you basically have image retrieval based on images of the products that's being done automatically, and of course automatically tagging flat sketches, which is basically pre-designs prior to the production of all the designs of fashion e-commerce products. Now, some of these companies here have already done the implementations of AI, and in particular vSense has used AI for e-commerce companies seen here, as well as used PyTorch within the firm. You have Uniqlo, Rakuten from Japan, Zalora, Reborns in the Southeast Asia space, all the way to Interpark in Korea and all the way to Bukalapak in Indonesia. Now, the first space you can see here is the APAC e-commerce application space, which is optimizing product discovery and conversions, is basically deep product tagging. And what you can see here is, given this image, you can automatically tag from the top suit all the way down to the dress pants and all the way down to the flat shoes. You can see, instead of you manually tagging them, there's this deep product tagging that can tag, okay, the sleeve style is straight, sleeve length is long, neckline is lapel, pattern is solid, and then maybe you have like a occasion which shows that it's special occasion, as well as the color of the suit, and all the way down to your footwear, which shows that it's closed toe and round shape, and maybe you can go all the way down to, you know, it's Oxford shoes and things like that. And this is compared to manual tagging, which has been done quite aggressively in a lot of the e-commerce space in APAC, but growing number of use cases is deep product tagging, and this is developing quite rapidly in this space that has shown solid results, both in terms of improving product discovery, be it on the website itself of the e-commerce companies or via SEO optimization, which is through the search engine of Google. With better tagging, it allows better discovery through searches on the various search engines in Asia Pacific. Now, the second part is smart recommendations compared to collaborative filtering being used. Predominantly, previously, we are looking at a lot of visual similarity algorithms that rely on computer vision algorithms. And for example, when you see a red dress here, you can see visually similar dresses compared to using collaborative filtering that relies on group user preferences and lumping them together. And this has shown marked increase in terms of the preference of what is similar. It allows people to search for shirts that are similar to what they like, for clothes, for shoes that they think that what they like, rather than based on group preferences done through collaborative filtering. Now, the last part is in terms of the retail operations. We can see information retrieval. For example, the dress shirt here. Given a scan of it on a mobile application, you can see that this is a plate button shirt. The SKU, which is the product number, followed by the location of this product on the different parts of the retail brick and mortar store, all the way to the number of stock count at the back. So this provides a really rapid way with a simple mobile application. Within less than a second, you can quickly have the right information retrieved just based on the image of the product itself. And of course, the last we see, which is growing and quite new, is flash sketch tagging, which is basically an automatic tagging for flash sketch and design concept. It allows people to basically compare, and the designers can compare when they design a particular product. They can see basically, okay, these products, we have like 20% of similar products based on this tags compared to our inventory. Have they been selling well? Am I designing concepts that are selling well previously? And this provides the insights that was otherwise not available in a very quick and scalable manner before that. And this is basically a really interesting, I feel, growing use cases that we see in Asia Pacific. Now, what I'm going to talk about is basically NLP applications in APAC, which I'm starting to see a growing number of use cases in finance companies. So we have talked about computer vision algorithms in e-commerce companies, which is growing in its prevalence there. But what we start to see in finance companies in the space of banks to asset management firm is basically the use of NLP applications. Now, the two use cases I'm citing here, again, this is non-exhaustive, but basically one of the common cases that we see that has worked quite well, and we see more use cases beyond this that are similar in nature, but of course across different functions. Now, the two main functions that we see that is working is basically trade finance automation. There are a lot of documents in the banks. When you have trade finance documents, basically your land and credit documents, your LC documents, which has been a manual process requiring many hours and many staff basically looking at all these documents, but basically there's automatic verification now of these documents by these algorithms. And the second part is basically financial analysis, where it reduces the need for manual information retrieval across I would say more than hundreds of pages, I would say thousands of pages of annual reports, quarterly reports, and other unstructured documents with very non-uniform data formats. Now with the use of NLP algorithms, it is much easier for banks as well as asset management firms to quickly retrieve the information in a very consistent manner that they can use to quickly build their analysis to analyze the different companies, commodities, or currencies that are relevant to them, and they want to do further analysis on. Now, these are the companies that have deployed using NLP algorithms as well as some use cases. And one of the startups is basically Six Estates. It also uses PyTorch. So you can see how they use, they are startup in Singapore, and they use mainly algorithms for intelligent document processing. And they're served, for example, DBS, which is the largest bank in Singapore. One of the proofs of concept usage is basically financial analysis automation. And in terms of the production use cases in the space of trade finance automation, we here have a use case of BCA, which is the largest bank in Indonesia, where we will be showing how does trade finance automation work. Now, in the space of trade finance automation, it's basically converting the LC documents, basically finance documents, automatically through OCR technology, which is quite common already and quite prevalent, and basically automatically convert those texts into a more structured form. Now, the second part, which is the harder part, is basically how you convert it and autocorrect all those information into structured data. And that is one of the main parts. So once these companies get it right, the information are majority correct, then the interesting part is applying machine learning algorithms, which basically can automatically do more smart compliance and regulatory checks to see whether these documents are complying with international trade standards. And this is basically in combination of existing hard trade rules as well as intelligent morphing rules to see beyond the hard trade rules what seems to be a common case of error that is not spotted and not incorporated as hard rule. And machine learning algorithms basically extract those as an anomaly, and then those are then converted to become hard rules for further iteration and implementation in this whole pipeline of trade finance automation. Now, the second part is financial analysis automation, which basically uses AI algorithms to automatically extract financial indicators and values from various documents. And the hard part is because a lot of these documents come in various different non-uniform format, and the right part is getting the algorithms to correctly extract this information and to perform automatic calculations based on predefined formulas. And I think more interesting is the use of deep learning algorithms to highlight various financial movements and important drivers of these stocks as well as event risks in that sense. And the last use case, which is after the first and second step, is basically integrating third-party data from corporate credit ratings, textual sentiment news, all the way to company announcement. We can then use it to supplement a more holistic recommendation on whether this particular stock have a particular unique proposition for a lot of the asset management firms as well as the banks in terms of how they want to recommend this stock. It allows them to automatically see things that they might have missed among thousands of pages, as well as real-time news and announcement that they are unable to manually monitor on a day-to-day basis. Now, the last part I'll be talking about is getting started for APAC companies from research all the way to production and adoption of AI. And I think the three main pillars that I'll be talking about here is basically the first part is theory and programming in deep learning foundations, followed by applied machine learning programming and practices. And the last part is domain knowledge as well as risk controls, which are required because no algorithms are infallible. They fail, and it's important to recognize that they fail and know when that they're out of distribution and you stop these algorithms. It is better to understand the limitations of them and have circuit breakers rather than assume that they work all or majority of the time. And also on domain knowledge, which is extremely critical for production, which is required to really produce high impact algorithms that actually matter to the bottom line of a lot of these APAC companies in Asia Pacific. Now, the first part is theory and programming in deep learning foundations. My recommendation is deep learning with PyTorch. If you're into reading, you really like to read, and there's a huge resource available for deep learning with PyTorch. As you can see here in the first recommendation, and that is where I would recommend people who really like a textbook style, which is more applied in nature. They have this whole huge resource where you can find practically anything under the sun relating to deep learning with PyTorch. And it's available open source on PyTorch website. The PDF file is in the resource that I'll be showing subsequently. Now, if you're a more visual learner and you want to talk about theory and programming and deep learning in the foundations, I highly recommend the course Deep Learning NYU, which is open source, of course, which is the whole part of my recommendations. Everything is open source, which is by Yan Khan, as well as Alfredo Canziani, who's a close friend of mine. And I cannot help but his courses have been well received, primarily because his visual representations of concept really aid people to understand the theory as well as the programming aspects of deep learning much more easily if you are a visual learner. So I recommend you to complement this video course with the book on deep learning with PyTorch. I think this resource goes hand in hand. One is the videos as well as the practicums, and first you have a textbook like to refer if you want to delve deeper in a particular area, or if you want to look at basically more exercises that you can look at. They also have it in that book. Now, when you move on to applied deep learning by applying machine learning programming and practices, I would recommend Made with Machine Learning by a friend who's Gokul Mohandas. It is absolutely amazing. I think his specialty is with production machine learning. I cannot possibly think of a better resource out there, which is open source, and his resource is really the gold standard here, I feel, that is on the open source scale. And of course, you have practical deep learning for coders if you want to get quick and started. It is less more on the full production at scale, which Gokul Mohandas provide, but it is a really good start on applied machine learning and basically moving these algorithms into real world applications quickly by, of course, Jeremy Howard and Rachel Thomas, extremely talented people. And the last one, which is Deep Learning Wizard, where we have some open source resources in machine learning programming, which is by myself as well, Tiefu, who's a close friend, who's in Mila right now. Now, the last part which I want to talk about, which is domain and risk controls. Now, the importance of domain knowledge, which I've seen through many companies, from e-commerce companies to finance companies, all the way to manufacturing companies, in fact, that the importance of domain knowledge is very important. Now, this world where AI has proven its significance in some areas in the world, it is not yet dominant in a lot of the traditional industry, which are the majority, I would say, of the companies in Asia. And because of that, it is important for us, as whether you're a deep learning researcher or you're an engineer, I think it's important to take a step back and understand the domain knowledge involved in these companies before throwing your pride or throwing algorithms at it. I think it's important to understand that what is important, what has not worked, and what are problematic in their use cases. And this helps you to design algorithms that actually matter. Now, the second part is algorithms break down all the time, and this is primarily due to out of distribution data. And it's important to basically monitor your data distribution and implement circuit breakers. I cannot emphasize how important this is, because algorithms will always break down. A key weakness, even in research, is basically out of distribution data, even in research, throws deep learning algorithms into a problematic state. And if you think about that and build it into a production state, you start to understand that it is an even bigger problem in reality, where there are more there are more out of distribution issues in the world. So that is why it's important to monitor your data distribution as well as implement circuit breakers before you push it into production. I cannot emphasize this more. I would say this is probably one of the most important things, followed by domain knowledge. And the last part, I think a lot of people are comfortable with versioning control for code. If you use GitHub, you know what's version control, you can see what's changed, and can control the different versions and roll back if there's an issue. But I think for the space of AI as well as PyTorch, it's important that a two new area which requires version control, and that is data and models. Now, traditionally, a lot of people think version control for code is like a de facto standard. But now, version control of data is also important because you need to see basically which part of your data has changed, how it has evolved, how it has affected your model, and it's important to see how the same piece of data may or may not have changed, accidentally overridden, and that is extremely important. And versioning control for models, so you can roll back your models, you can look at the models that have worked. So if you've done something really bad, you can make sure that you go back and see, okay, I have a model that I can go back, or basically just to see the improvement of your models. When you have version control of your models, you can basically see the improvement or worsening of the performance of different models over time in terms of your production as well as research use cases of AI. Now, the last part is the 3 stages of getting started in AI. PyTorch, I would say, moves from education to proof of concept to production. Now, you don't just want to run in production. I think it's first important to get all the stakeholders on the same page. And for that, you need to start with education. And the use cases here, one thing I've done with is Eastspring Investment, which is one of the larger asset management firm in Singapore. I've gone through with their quantitative strategies team in Singapore, where we walk through applied AI in PyTorch. And when they get comfortable, then only you can move to proof of concept followed by production. So a case of proof of concept is basically DBS, where there's a financial analysis automation to show that, hey, now we know the use cases, how these deep learning algorithms work, the limitations of it. Now let's work to use a small use cases and prototype and see how it works. And only then you move to production, where you know you're educated on how it works, how to maintain them, and you have a use case of how it works in a small use case, and now you're going to push it to production. So it's always important to move in this 3 phase: education, proof of concept, production. Never ever jump all the way to production or just jump to proof of concept, because it always starts with education. Now, even though you're very experienced, it's always important to let the executives, management, or all the stakeholders, not just management, but all the different stakeholders, to know that this is how it behaves, this is how it produces results, these are the scenarios where it fails. And we have all these protocols, as well as monitoring and backup solutions that will kick in place if these algorithms fail. And this is the kind of education process which is required to basically gather consensus to know that, yes, these algorithms can produce good results for the bottom line of all of these APAC companies, but it's also important to get their consensus and education on that front, is because then everyone know that, okay, there's a possibility where there might be errors, and everyone's on the same page to say that, yes, these are errors, but we know it, so let's continue to improve them, rather than different stakeholders getting shocked by certain failures and shutting down the whole project, which defeats the purpose. So I call this more like a stakeholder building, from education to proof of concept, followed by production. Now, the last part is basically the resources link. The PyTorch.org Deep Learning with PyTorch book is the one where I told you there are a lot of written resources, absolutely amazing products. The cds.nyu.edu is, of course, Yana Khan and Alfredo's visual course with a lot of beautiful videos. If you love colors, if you love a very visually stunning way of explaining deep learning concept as well as programming, please go ahead. And you have Fast AI, which if you want to get started for small production use cases of AI, please go ahead. And of course, Made with ML, which is by Gokul Mohandas. Absolutely amazing production resources. I would say please go ahead. And if you want to start with a very rudimentary applied deep learning, you want to see whether it's for you, the website Deep Learning Wizard provides some initial resources for you to understand more. But I would say my recommendation in order of preference, as you can see here, theory, which is on PyTorch website, to NYU course, followed by production, Fast AI as well with madewithml.com, which is by Gokul Mohandas. And with this, I'd like to thank all of you. I'm really interested, the companies I've seen in Asia, growing adoption of PyTorch. I would say PyTorch in production is something which I'm really happy to see, and starting to see being prevalent in a growing number of startups as well as MNCs for PyTorch adoption. And although research has been kind of a very prevalent market space for PyTorch, even in APAC, I think one of the interesting developments I hope all of us take away here today is that we have this framework that we can leverage on from research to production, and the use cases that we can see that can be done, be it not just on the research side, but on the production side, to deploy algorithms that really impact customers in the APAC space. And with that, thank you for listening, and I hope to see all of you around, and happy PyTorch Ecosystem Day.
Okay, welcome to PyTorch Ecosystem Day 2021. Thank you so much for being here. So excited. This is great, such a great event, such a great way to get the community together, and a really nice follow-on from the Dev Day we did last year. If you don't know me, I'm Joe Spisak. I'm the product lead here at Facebook for PyTorch. And if you're part of the community, hopefully we know each other. If not, please reach out on Slack, reach out on GatherTown, find me later. I would absolutely love to connect, and hopefully you enjoy the keynotes from some of our most prominent community members, Peter Bilecki from NVIDIA, as well as Ritchie. They're so passionate, such amazing people, and really proud to have them speak on behalf of the community. So today, I really just wanted to update everyone on the releases we have, some of the newer features that we have as part of these releases, and I wanted to start with just giving everyone a feeling for how we do releases and how we classify features. I think this has been something we've done in blog posts in the past, but just wanted to give everyone a refresher on the approach for how we actually do these major releases, which are getting larger and larger and larger, by the way. So first off, we do releases every 3 months, so they've gotten quite large again. So I think the last one had well over 3,000 commits between releases. So, man, with over 1,800 contributors, there's a lot of code being pushed into the repo, so the project is getting quite large. We also do maintenance releases. So 1.8.1, which is a maintenance release, is a bug fix release, no features. And we try and do that. We try and have that kind of TikTok strategy of major releases and minor releases if we need them. And it kind of helps, keep hopefully a good user experience. We also release on Conda, PyPy, as well as Docker. Those are the main distribution points for the project. We have docs and tutorials on PyTorch.org that are programmatically built and tested. So we have CI there, and that's maintained by our doc engineering team, but has a huge amount of contributions from the community around tutorials, doc fixes. Please keep those coming. The more the merrier. We'd love to see the experience continue to be improved. As far as releases go, this is not something we have a post on or anything, but how we think about features. So I think if you look at the PyTorch.org site, we have the feature classifications, whether prototype, beta, or stable. But one thing that we started doing well over a year ago is actually doing a deep dive into every single feature, major feature that we include in the release. And so this is things like testing or breaking changes. Could also be feedback we've acquired, or the API experience, or op coverage. But we go through this very rigorous process for each feature, and it tends to be a very detailed kind of 2-page or 1 to 2 page document that someone puts together, and we take a look at it, and we figure out, number one, are we going to include this feature in the release? And number two, like, how are we going to classify it? We want to set proper expectations for every feature that we release. And to give you an idea, in the 1.8 release, we had something like 41 features that we reviewed, across the project, and that we dove deep on. So it is quite rigorous, and we do take a lot of pride in delivering a great user experience across PyTorch. Fifthly, we started doing about a year and a half ago RCs, so release candidates with every release, and we typically release these about 1 month ahead of an actual public release. And so we're, with 1.8, I think we generated something like 5 or 6 RCs. We fast iterated when we saw cherry picks that we had to pull in. This is a great way to test as a community, to give feedback early on before the release actually gets cut. So if you're interested, please reach out. on the Slack. Yeah, again, like it'd be great to get other eyes on these RCs, so we can make sure that we've addressed issues, but before we've actually cut the binaries. And then lastly, cloud support. So one of the goals we have is to make PyTorch as broadly available as possible in the most used platforms. So we do work with Azure, work with Google, and we work with the AWS folks to make PyTorch releases programmatically available in everything that they deliver, whether it's things like AMIs or VMs, all the way through to platforms like SageMaker and otherwise. And so our goal there is to basically have a currency level that is very close to time to market with our releases. It doesn't always happen that way. It tends to be more of the days or weeks, but our goal is actually to make that turnaround or that cycle time as quick as possible, so you have the latest releases on all the clouds. So hopefully we continue to improve in that regard. So looking at the actual feature classifications to provide kind of a click down and a little bit of color, we typically classify releases in three ways. Prototypes are bleeding edge features. These are features that probably aren't going to be in the actual release itself. They're typically behind a flag, or they actually tend to be more likely in nightlies. And this is actually a good thing, because bleeding edge features are typically fast moving. There's going to be a lot of small fixes, a lot of new pull requests that pop up to make things to improve things, and we want people to be able to quickly iterate. And so we tend to focus our prototypes there. We also have prototype recipes and tutorials and PyTorch.org that Holly on the doc engineering team created, which are really amazing. And so you can actually play around with some of these prototypes in like Jupyter notebooks and so on in Colab. It's really beautiful. Next is the beta level features. So these are features that are typically more committed, and we're basically committed to seeing these through stable. So in prototype we can kind of fail fast if we need to as a community and find areas that maybe aren't worth investing in or worth investing in, and then we typically will take those to the ones that we want to take forward into beta. And beta is going to be part of a release. Typically, it's pretty feature complete, but maybe isn't performant, or maybe it doesn't have full documentation, or maybe it doesn't have full op coverage, or whatever. These features are also not committed for backward compatibility. So again, these are typically very very well implemented features, but they are being iterated on somewhat. So the API may change or whatever, but they're basically a number of features on the project that are kind of in this state. And what the hope is really to graduate those features into stable. And stable features are performant, well documented, typically have full op coverage, and from a breaking changes perspective. The goal is to basically have them as stable without any BCs. BCs, of course, still happen, and we do typically roll those over multiple releases. Typically have a warning, and then we'll do a deprecation. More realistically, though, we will actually keep things around for a long time. We want to make sure that we don't break people unless we absolutely have to. So now I want to just click down into some of the newest features from the latest release, just to give everyone a flavor of what we have going on. So starting with the front-end APIs, we have this thing called torch.fx. So this is a feature that was we didn't actually think it was going to get as broad of attention as it got, but the team was really pleasantly surprised on how excited people got over this. And so really this is all about functional transformations in the Python regime. So this is Python to Python code transformations. And more specifically, things like transforming your NN module. And so let's show a little bit of code and talk a little bit about more what torch.fx is composed of. So the actual toolkit, or the components are, number one, a symbolic tracer. Number two, an IR. So it has this thing called fxIR, which is its own intermediate representation. And then three, it has a cogen in Python. So really three steps. One, you acquire a graph. You will, number two, write a transformation or write a pass. And number 3, you'll generate a new module. And what we've seen actually is this is great for implementing things like quantization. So the new graph mode based quantization that was released in prototype fairly recently actually uses this under the hood. So we call it the FX graph mode quantization. We've also seen improvements in performance. So if you're serving, for example, your models, and you can actually write passes and do improvements and get latency benefits. And there's also some benefits, obviously, in training as well. So anyways, this is a general toolkit that please check it out, give us feedback, and let us know where you're seeing value. The next front-end feature is torch.linaug. So one of the big areas that we've invested in over time is really being as NumPy compatible as possible. So the next 2 features here are really all about that. How do we align so closely with NumPy's API such that very minor code changes allow you to take advantage of all the greatness that NumPy has, but also all the goodness that PyTorch brings, things like AutoGrad, things like GPUs. So torch.linaug module basically mirrors the np.linaug namespace in NumPy. So this is, again, things like Cholesky decompositions, determinants, eigenvalues, and again, very small code changes allow you to take advantage of all the goodness of PyTorch. Same thing with FFT. So this was a feature that we released in beta previously. It's now in stable. This is, again, NumPy style compatibility. So literally swap in your MPs for torches, and you basically get all the advantages of GPUs, AutoGrad, etc. And we're starting to see this be used in broadly in scientific computing, which is really cool. So moving on to performance optimization and profiling. So this is actually a fairly big release we did in partnership with both NVIDIA as well as Microsoft. And what we've actually done is created this new namespace called torch.profiler. And underneath this namespace, there's actually a library called Kineto. And Kineto is in the PyTorch org. It basically provides the GPU monitoring capabilities and tracing. And there's also a TensorBoard plugin that is available in that repo as well. So we have a new API, we have GPU monitoring, we also support, of course, CPU. And there's a TensorBoard plugin, and this can actually be used in your VS Code. So you can actually be in your IDE using TensorBoard, profiling, and doing all the things you'd love to do in PyTorch, kind of all in one place. And so some of the things that it brings is the ability to, obviously do your profiling of at the kernel level, looking at mem copies, etc., find the bottlenecks, be able to provide recommendations. So in this case, it's looking at your step time breakdown and actually telling you that, hey, like 21% of your time is actually being spent like loading data. That's a problem. So there's areas where you can actually improve there. So overall, basically, it provides you the ability to just generally performance profile and do some actual active improvements to your code. And then I mentioned you can visualize in TensorBoard, so you can visualize at the thread level, and then you can optimize and understand what's going on at the op level. And there's a number of different visualization ways you can look at this. So you can actually look at say like the top, pick your operators and understand which operators end up being the bottlenecks. You can actually slice and dice in a number of different ways. So this is really, really nice because you're already typically visualizing, things like your training loss curves, maybe your data, and now you're able to profile your code as well, all in the same place. So we're really excited about this. This is already getting a lot of excitement. And then the last major feature area I want to talk about is distributed training. Distributed training is, of course, part and parcel to how we scale into the trillion parameter models, how we, how the really innovation happens. How do we, increase our iteration speed, and so, a lot of things we've been working on, for example, like our RPC framework or TensorPipe, or some of the things I'll talk about here in a second, are all in service of training bigger, faster, and enabling either research or production scale models. So, if you look at some of the new features in beta, pipeline parallelism. So, giving a shout out to Mandeep Bains over in our Fair Scale team. we're looking at Fair Scale as this feature library that is really pushing the state of the art. It's a really cool library that has a number of bleeding edge capabilities, and this was one of them. And we actually worked really closely with that team to bring this into PyTorch Core. And so, for example, when you're training with your traditional DDP models, and you can't fit in a single GPU, this is actually a great API to try. It's a pretty simple API. You include it in part of your training loop, and this should certainly allow you to scale even further. The other feature I want to just call out is our DDP communication hook. This is almost a framework or a toolkit in itself. But basically what it does is it allows you to bypass the vanilla auto all reduce in DDP and actually insert your own communication strategy. And this is really interesting because there's a number of like built-in communication hooks that are just available at release. So we did include, for example, Power SGD and for gradient compression, which we've seen quite a bit of benefit actually in scaling some models internally. So we'd love to see what benefit it brings for your models. But you can actually apply new strategies. So you can actually define your own communication strategy, plug it into this communication hook, and try something out yourself. So this is great for using out of the box strategies like Power SGD, but also from a research perspective, it really gives you kind of a tapestry to ideate on and create your new strategies and hopefully enable new research. And then the last thing I'll mention is, this was something that we've been working on for quite some time with the AMD team. We've been released in beta support for AMD GPUs. This is now in the install matrix. You can go to pytorch.org. You can click on the ROC-M. We support 4.0.1, I believe, right now. And those are programmatically available through pip. And you can basically get AMD GPUs out of the box. And again, this is in beta, so we'd love to get feedback and let us know what you think. And we'll continue to work with the AMD team to improve support. So if you want, reach out to me, Jay Spisak. You'll find Jay Spisak on Slack. You'll find me on Twitter at Joe Spies. But if you're in the Gather town, please reach out. Love to chat, love to catch up, and enjoy the conference. Enjoy Ecosystem Day. And thank you, as always. Thank you for being part of the community. And absolutely love this community and love what you do. So keep on, and cheers. See you soon.
Welcome everyone, excited to have you join for the PyTorch Partner Collaborations talk. My name is Geeta Chauhan and I lead the PyTorch Partner Engineering at Facebook. We will look at partner integrations and dive deeper into the profiling models, scaling AI in production, ML ops with Kubeflow pipelines and ML flow. PyTorch ecosystem is rapidly growing and we put great emphasis on PyTorch as a platform with a wide range of ecosystem partner integrations built on top. These range from libraries like Hugging Face, OpenMind, to all the cloud provider integration and newer solutions like the MLOps platform integrations. Next, we will dive deeper into a few of these. For profiling models, we collaborated with Microsoft for the new PyTorch Profiler with TensorBoard Profiler plugin. We open sourced Facebook's internal tools for GPU monitoring as the Kineto library, which is built on top of cupd, and Microsoft contributed the Profiler plugin for TensorBoard along with VS Code integrations. Now one can see both the GPU and PyTorch level traces in a single view with actionable recommendations. It is a simple pip install for the Profiler plugin and comes with views for timeline tracing, high-level overview with recommendations, operators, and kernel views. Just call the import torch profiler and then set the context and pass parameters like GPU, CPU, activity tracing, record tensor shapes, and then in the training loop, call the profiler.step for the traces. In the timeline traces view, one can see all the CPU threads and the GPU streams and see all the PyTorch A10 ops and the CUDA kernels and user annotated record functions. One can see the flow of events from CPU to GPU and identify bottlenecks. You can inspect stats for individual activities. In this example, NVIDIA SMI shows 86% utilization. However, only a small fraction of the streaming multiprocessor on GPU are actually used. After we increase the input size, the WOPS per SM utilization looks much better. Here is an example of call stack for the PyTorch Lightning integration. All you have to do is launch the Lightning training with --profiler flag set to PyTorch, and it automatically generates all the traces. Let's look at the overview of the profiler. You see here that we ran the test on a single GPU machine with one worker. You can see the execution time breakdown and the step time breakdown. And in the recommendation section, you can see the run is taking long for the input data loading with 20.8% of step time at data loading. It is telling us to set the number of workers on data loaders and enable multiple processing. Let's look into the actual code. You see here it's a simple CFAR10 model, and we are loading the data with default number of workers. And then we set up the profiler context and we do the zero grad backward and then do the actual optimization. So let's increase the number of workers to 10 now and see what difference does it have on the profiling. So we run the profiler step again and we can then see the output and see what is the difference. In meantime, let's look at the operator view. So you see here all the operators, top 10 operators are shown. In the GPU kernel view, we can see the top GPU kernels, you see the cuDNN kernels, call time, duration, etc. Now the second run completed and we see that the extra time for data loading is gone and the time has reduced to 125 milliseconds. Let's look at the trace view as well. So in the trace view, you can see the profiler steps, the different steps that ran. You can select a bunch of kernels and see the details in the section below. You can select the GPU kernels and see all the details, the cuDNN kernels that are getting called. You can pan and zoom, go into the details of a specific profiler step and see all the optimization and other steps over there. So here we have the details of the GPU traces, and if you select a particular kernel and click on the launch for it, you can see how the flow is going from the CPU to the GPU. Now let's look at the tensor board in the VS Code. So we launch the tensor board command and you can see here that the tensor board is loading inside VS Code. And you can see all the same views, the overview, operator, kernel, etc. You can move around, see all the details. So the two steps that we had run with and without the optimization, all those are visible here. So this is with the optimization. And this is the previous step that we ran. You can also see the trace view inside VS Code. So here the traces are loading. You see all the steps, the profiler steps. You see the CPU streams at the top and the CUDA stream at the bottom. There are two CPU streams and one CUDA stream. And you can dive and see that the profiler step has the optimizer step SGD. You can dive in, see the details. It takes 260.025 milliseconds. You can select a set of GPU kernels and see the details of those. For the scaling AI in production, in partnership with AWS, we launched TorchServe for model serving last year. It provides a scalable solution with model management, inference, and matrix API. It comes with default handlers for all the common ML tasks like image segmentation, text classification. One can write own custom handlers. It supports model versioning with rollbacks. And now one can do auto-scaling with Canary rollouts and monitor using Prometheus and Grafana. We added support for a range of integrations, the Kubeflow KF serving with Canary rollouts, MLflow integration, Captum for model interpretability, AI accelerator support for AWS Inferentia, support for Kubernetes and all major cloud, the AWS, Azure, and GCP. A wide range of deployment models are supported across the different clouds and on-prem based on your needs. For the ML ops with the Kubeflow pipelines, in partnership with Google, we are currently working to integrate PyTorch into Kubeflow pipelines for model training with hyperparameter optimizations, visualizations in TensorBoard, Captum interpretability. We already launched the standalone integration of model serving with KF serving 0.5 release. This is what the full pipeline will look like, and we will provide sample workflows for computer vision and NLP use cases. So you will start by identifying the problem, collect all the data for analysis, choose the ML model and code your model, and then you will run the experiments in the Kubeflow pipelines using your PyTorch model training and do the hyperparameter optimization using Axe and PyTorch. And then in the production phase, you will start with the transformation of the data where the PyTorch data loaders and the preprocessors will be used, followed by the training of the model, and then the packaging and deployment of the model on TorchServe KF serving. And for model monitoring and the performance tracking, you will take a look at PyTorch Profiler, Captum, Prometheus, and Grafana. The KF serving integration with TorchServe was launched back in Feb as part of the 0.5 release, and we are now working with Kubeflow pipelines. So let's look into a demo. So what you see here is a simple example of Kubeflow pipeline deployment. So this is a Jupyter notebook where we are doing the pipeline deployment. So we are connecting to the cluster here, giving the authentication details. So then we are calling the actual experiment, specifying the deployment task, and this is what the Kubeflow pipeline looks like. So this is for the BERT model, then the pipeline is processing. So here the PVC was created, the model was downloaded, packaged, and it was deployed, and you can run the prediction and get the inference results. So for the MLOps with MLflow, in partnership with Databricks, we had launched the first phase of integration of MLflow with PyTorch last year with support for automatic metric logging for PyTorch models. We had added ML model integration with the examples for Hugging Face BERT and many more. For the model registry, we added support for saving the artifacts and also the ability to save and load Torch scripted models. And we had built the TorchServe MLflow deployment plugin for serving PyTorch models from MLflow itself. Now we are adding new features for support for Captum for model interpretability, support for model signature verification, and hyperparameter optimization using Axe and PyTorch. So the code that you see here at the top is for Captum integration, and you see the visualization at the bottom. And then the code at the bottom right is for the model signature. So this, if you want to do signature verification when your model predictions are being run, you can do that now with MLflow. And this here is what the code example looks like for hyperparameter optimization integration with Axe and PyTorch for best parameter search. Thank you all for listening. Please reach out to us on GitHub. Do contributions. We are looking forward to doing active engagements with you. Thank you all very much.